Reminder, I'm going to come check your homework today. Like I sent an email yesterday, like I told B-Day, because I need to make sure. Honestly, I should have checked before today, but I need to make sure that y'all are staying on top of your stuff. You have to have this turned in on the day of the test, which is next week. I'll put the calendar in a minute. But I am checking to see, after I teach this lesson, if 4.1 is done. That should be done. You can fit 4.1 on this page. 4.2 should be done. You can fit 4.2 on here. But y'all, 4.3 and 4.4 should be done. If you crammed all of that multiplying and factoring on this paper, I am thoroughly annoyed. And you need to not do that again. Get yourself some paper. Get yourself a spiral. Just hang on one second. Get yourself a spiral and write 4.3 and do your work in a nice, orderly fashion. Those papers are going to be collected. Don't tell me you threw them in the trash. Don't tell me you blah, blah, blah. Whatever excuse I've been getting, keep up with your score. Before we move on, I do want to talk about two problems on here that just in the past 2 days with tutorials, some of this has gotten fresh on my mind. That is 27 and 28, okay? 27, listen to what I'm saying. I never, ever, 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 ever want you to factor, which is in this section, with a negative A value, okay? Can you take out a GCF, numeric GCF, between 2, 13, and 15?
No.
Yeah. No, not well. A number other than 1, negative 1, no. But if you did not start by factoring out that negative, that would be my suggestion. This wasn't in the notes. I didn't even realize it was on the homework till someone asked me in tutorials. The first thing that I would do is, if it does have a GCF of negative 1, you do need to take that out. So we could rewrite this as negative, and then you're factoring 2x squared plus 13x plus 15, blah, blah, blah. Do the whole spiel with this 2x squared plus 13x plus 15. I just think the method, again, I do grouping. If you've got a negative A value, it does make it really confusing. So I don't ever want you to factor with a negative A value. Just divide the negative out from the get-go, okay? If you didn't do that, you would have to take it out at the end. But the thing is like leaving a factor, don't write this, but leaving a factor like this, I don't know if it's what it was, but this is not fully factored, okay? That's like leaving 10x plus 8. We don't do that, okay? So that's not going to go. So take it out at the beginning. I think it's easier to take it out at the beginning, but you can take it out at the end. But we should take it out at the beginning. The other thing that I came across and I didn't realize is, what form is number 28 in?
Vertex.
Did I teach you how to get from Vertex straight to factoring?
Yeah.
No, not Vertex form straight to factored form. Not a straight transition there. So how do we do it? We have to make a pit stop.
You add 4 to the 4.
You do it to like a 0 form, and then you just like multiply them together to get standard.
Turn it into standard. Standard is your connector. It's your connecting form between the two. So turn this to standard by doing 4.3. And then you'll have standard form. Then you can go to factored. So sometimes you kind of have to make a pit stop there. Okay, you're going to have to do that on today's lesson. All right, so I'm sorry I didn't catch that last time. I'm just struggle bus here. Yes?
Could
Your
you
question.
go over 27?
27. Does taking out the negative help?
I tried doing it both ways. I couldn't get it.
Okay, I'll come over during work time and I will look at it with you. Because it's not too bad. You do have to group it, or
I got this, and I put into the mathematics page right.
you didn't have a negative. Okay, that's not fully factored. It's not fully factored. I'll show you what to do. Just hang on to those. Put a star by those. And when I check your homework, I'll look at it, okay? I will. All right. Everyone, look at 4.5. This is your homework for today, okay? There's a change that needs to be made, and it's on number 33. Number 33, it needs to be 4 times x minus 4. It currently says x minus 3. Change that to be a 4. I promise it'll make your life easier. Times x minus 2. This is another one of those problems that you're trying to get it to Vertex form, and today I'm teaching you how to do that. but I'm teaching you how to get to vertex form from standard form. So this is another pit stop problem where you're going to have to get to standard, then do what I'm about to teach you. And then on number 34, some people came and had questions with this. This is kind of a throwback to 3 forms. It just says, hey, here's a graph. Write all 3 of them, okay? So it's pretty similar to question 13, where I only had you write 2. The last one, you're able, now that you know how to convert between all of them, you can do all the things. But you will need to make sure on 34, it's this graph. You need to find some attributes. You need to find your A, and then you can write in all 3 forms, okay? But again, I'm going to come around and check that, and if y'all have questions about specific ones, I should have time to be able to kind of look at that because the lesson isn't super long today, but it is important. So homework papers to the side. I don't want you working on them right now. Put your white packets to the side, notes packets out, okay? So today is the last day of new material. We're going to be on page 19. Please don't work ahead. Listen to what I'm saying right now. Today's the last day of new stuff, okay? After today, you should be able to get your entire homework packet done. I will be checking 4.1 to 4.4. If you don't have that done, you have until tomorrow, 4th period, to email me a scan of your work or come find me in tutorials. If you don't have all 4 of those, you're on a list and you're getting an email home at the end of the day before your weekend to your parents that says you're behind. And there's no excuse because this has been going on for 2.5 weeks now. So if you're not done, hopefully you are. It's 4.1 to 4.4, so I'm checking today. But if you don't get 4 check marks, you got to email me or find me by tomorrow, 4th period. Got it? Yeah? Otherwise, I'm going to do my best to ruin your weekend. Haha. Just kidding, sort of. Okay? So today is the last new thing. Next week, we're going to take a check for understanding over all the converting. So it's like 4 questions. We may not do it like right at the beginning of class. I might give you 15 minutes. Please stop tapping. I might give you a few minutes to kind of review your stuff. But we have a CFU. You have a test review, which the test review is due the day of the test. So is the packet. So I really want to stay on top of that packet so that way, number 1, you're not bogged down with homework before the test. But also, number 2, you know what you need to emphasize on review day, what you need to focus on, like how you should structure your review time so that way you can ask me for help that you need, okay? It's all just to try to make things easier on you. And then the test is next week. It is 2 separate grades. Transformations in 3 forms. I will pass back that check for understanding that y'all took a while ago. I'll pass that back next time. And then again, we have our second topic, which is just all about the converting. The converting topic is probably going to take you longer just because these algebra processes take a little bit longer than transformations. Okay? So, page 19. Today's focus is all about, this should say 4.5. Sorry about that. It's all about going from standard form to vertex form. Okay? To do that, there's more than one way to do this in life. The way that we are going to do it is by a process called completing the square. And it's important that you do know how to do this. So this is what we're focusing on here. I want you to recognize that instructions because I am going to tell you on the test, convert it by completing the square. Guys, white homework packets on the ground. I don't want to see white homework packets on your paper anymore. I want golden packets of notes only. Packets on the ground. Today is too new. It's too new and too important that you learn how to do it. It's not going to take me that long. Even with all the mess that was 3rd period today, they still had 20 minutes to do their homework, okay? So here is a quick warm-up. Factor the following, okay? All of these trinomials, what do they have in common? First thing.
They're in standard form.
They're in standard form. Their A values are all 1. What did I classify trinomials with the A value of 1? What did I call those? Easy factoring. But basic works too. But this is easy factoring. And why is the only reason that it's easy? Because A is equal to 1. And I need y'all to know that, and I need y'all to recognize easy factoring versus not easy factoring. Not easy factoring is when your A value is anything but 1, okay? So there are some homework problems on 4.4 where once you take out a GCF, A becomes 1. That is still under easy factoring. But if you check for GCFs, you take out everything you can, and there is an A value that ain't 1, then you have to do the whole shebang. The whole process, you will have to do that on the test, so make sure you practice it. But these guys, these are going to be quick. So remember, with easy factoring, I said all you really need to do is the number puzzle. So let's review this first one. Quick recap. What goes at the top of your number puzzle? A times C, which in this case is 1. What goes at the bottom of your number puzzle? B, which is 2. Make sure you get the sign with that because these kind of alternate between negative and positive B's. So what are two numbers that multiply to be 1 and add to be 2?
1.
1 and 1. Now, when you have easy factoring, all you have to do is set up your factors, which will start with X, and then you just take those number puzzle winners and put them into the factors like this, okay? The reason why this is considered easy, the only way to get X squared is to multiply X times X. So that's kind of why the numbers just slide right in there. How else can you write this?
X plus 1 squared.
X plus 1 quantity squared. And that's what I want us to get to today because that's kind of our giveaway with Vertex form. So if you do your number puzzle and the two winning numbers are identical, that means your factors will be identical. That means write it once, square it on the outside. Okay? Do those real quick. Go. Yeah, if y'all get to where, again, especially with easy factoring, we will get there as a class. I'm going to keep doing the number puzzles for now just because this is still recently new. But yeah, if you don't need to do the number puzzle on your paper, don't. Just go straight to your factors. It's fine. Okay? All right, what is the middle one? X minus 2 quantity squared is how you say that when it's a binomial squared. The next one is X plus 3 quantity squared. Then the last ones are X minus 4 quantity squared, X plus 5 quantity squared, X minus 10 quantity squared. Very good. Again, if you don't number puzzle those out, I am not going to count that wrong. Okay? Because if you can do this in your head, I want you to get there. I want you to get there. But if you need it, then use it right now. Because this, again, is still fairly new. If your A value is not 1, then I expect to see the X and I expect to see a whole process. Hopefully I've converted you to grouping. If I haven't, I need to see something else that's one of those processes that works and being able to get your trinomials there. But we're going to kind of break from factoring for the rest of the day today. Okay, but it's not going away. We're going to break from it, from hard factoring today. So what did we notice about our factors? Every single time. They were the exact same factor. So we were able to write it as the parentheses squared. So what that is called is when you have the exact same factor squared, it's called a perfect square trinomial. Have y'all heard of this at all? Do y'all know that pattern? Trinomial. You don't have to have this pattern memorized by any means. I'm not going to ask you to regurgitate this, but it will make your factoring life a little bit easier if you do recognize it. So there's two different cases. We can have the case where we have a factor A plus B with a plus quantity squared. And then there's the case where you have two things being subtracted. So you can see we kind of were alternating between sums that were squared and differences that were squared. The factoring pattern for both is very similar. All of our trinomials that we started with were very similar, but there is one difference that has to do with the plus or the minus. So here's what this factoring pattern or this multiplying pattern works out. If you have a sum that is squared, the exact same thing, it's going to end up being this. A squared plus 2AB plus B squared. Okay, that's just how the multiplication is going to work out. Again, you don't have to memorize this. Don't stress about it. I just kind of want to show you where some stuff comes from here. And then the only thing that's different is if there is a subtraction between them. What do you notice? When there was a subtraction between them, what happened in the middle term? It was subtracted. Minus 2AB plus b squared, okay? Again, it's just a pattern that happens when you are squaring the exact same factor. Just like with difference of squares, that's a pattern that happens if you're factoring matching factors, but one's plus and one's minus. So it's something, has a special name, but this is kind of what we're getting to, and this is how we're going to use it when we get to vertex form. So why am I stressing binomial squared? What's our giveaway that something is in vertex form?
The square.
It has a binomial squared, okay? So this is what we're needing these guys to be in vertex form, okay? So here's our process. How to complete the square. We're going to start out a little bit basic. There's not, I say like easy factoring versus hard factoring, I feel like that's kind of a night and day difference. With completing the square, when the a value is 1, yeah, technically it's a little bit easier, but it's not like night and day difference like it is with factoring, but it is a small amount easier. So we're going to start with that, and then on the back page, we're going to do a couple problems when the a value is not 1. The good news is this is a lot faster process than factoring. It's not as much like multiplication facts that you're like racking through your head trying to do that puzzle. But these steps, again, you've got to know the steps and you have to kind of know what order and how to do it. Okay, but the mathematics behind it isn't wild. I have to review myself every single year before I teach this lesson, like what the steps are, because I don't use it that much. So we need to make sure we're really practicing these, we're knowing these, so that way these are pretty easy questions on our test next week. Okay, are you with me? If you are not locked in, you need to get locked in now. Okay, otherwise you're going to be very confused. So this is the way that I do it, just kind of like with factoring. I kind of have my certain ways. There are some variations that you can do, but ultimately it's going to get the same step. But my step 1, this is kind of where you can have a little wiggle room here, is I always move my constant over. So when I'm looking at number 1, y equals x squared plus 6x plus 4. Ooh, quick review. What form is that in? Standard. This is in standard form. What do we know?
It gives us the y-intercept.
Y-intercept, what is the y-intercept here?
4.
Order pair. Why do you not flip the sign?
Because it's on the.
Because it's not in parentheses. And so this y-intercept, our c value, that is our constant. Constant means a number with no variable. So the first thing that we need to do, that I like to do, is just move my y-intercept to the other side of the equation. Now this is an equation. So you move stuff across your equal sign by opposite operations, and you always got to keep balance. So if I want to move this positive 4 to the other side, what am I going to do to it? Subtract it. So I have y minus 4. I can't combine those. And that's equal to x squared plus 6x, like that. That is step 1. Not anything crazy. Just move over the y-intercept. Okay? Now, step 2, my goal in theory is to make the right-hand side a perfect square trinomial. I want to turn it into a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared. So I'm going to manipulate this equation. I'm going to tell you how, but remember, it's an equation. So if I manipulate the right-hand side, I also have to manipulate the left-hand side. So it's all about keeping it balanced here, okay? So here's what I'm going to do. I'm going to change it, but I'm going to keep it still equivalent on both sides. Your instructions are right here. You're going to take your b value, which is the number in front of the x term and its sign. So if it's a minus, you're going to have a negative number. If it's a plus, you're going to have a positive number. And we're going to take that, which remember, that's our 2ab right here. So we're going to take this number and we are going to divide it by 2. Every single time that b value will be divided by 2. It has to be, okay? Because there's 2 of them in the multiplied out form. What is 6 divided by 2?
3.
Then we're going to square that because b squared. So what is 3 to the second power? 9. This is the number that I'm going to add in on both sides of my equation to keep it balanced, okay? So I'm going to rewrite my equation. It's going to say y minus 4, but I'm going to do a plus 9 on the left, and that's okay as long as on the right-hand side I do x squared plus 6x plus 9 on the right. So this is going to go on the left, on the right, the squared guy. Are we okay so far? Okay, honestly, that's not as much math, but we're getting close to like the amount of math we're going to have to do. So now I want to, step 3, I'm going to factor my trinomial over here, but I'm also going to clean up this side because what's going on over here on the left-hand side is I'm now going to have 2 numbers that I need to combine. Y minus 4 plus 9. How can I simplify that? That becomes what?
9 minus 4.
Y what? Plus 5. You combine. They're on the same side, so combine them together. Negative 4 plus 9 gets me to plus 5. Okay? That's about the extent of mental math you're going to have to do in this. Divide by 2, square, clean it up. Okay? Now on the right-hand side, I'm factoring this trinomial. Okay? So I'm going to do a number puzzle. It's easy factoring, right? Because the A value is 1. So on my number puzzle, what 2 numbers am I trying to multiply to be? And I'm trying to add to be?
6.
And what are those numbers? 3 and 3. So when they're the same number, then how many times do I have to write that factor? Once. But then I have to do what? Square it. Okay? Guess where that plus 3 comes from right here?
Oh, that's what you added. Wow.
So technically, you shouldn't have to do this little number puzzle here because it should work out that the b divided by 2, positive or negative number, slides in here. It's good practice just to like make sure that works, but if you added in the correct number, created your perfect square trinomial, it's this guy that should slide in there every time. Okay? And then final answer, hold your question. You have a question?
Yeah.
Okay, hold it real quick. Final form to get to vertex form, what do I have to do? Subtract the 5. So my final answer will be y equals x plus 3 quantity squared minus 5. Okay? Review time. This is your answer. This is your vertex form. What do we know now?
The vertex.
What is our vertex?
-3, -5.
Our vertex is an ordered pair. Why'd you flip the 3? Why'd you not flip the 5? Okay, what else do we know? Let's talk about a couple other things. Review. Keep holding your question. What other things do we know? We knew the y-intercept because it was in standard form. Now we converted it to vertex. Now we know the vertex. What else do we know? We need to know this. You got a test on this next week. Concavity. How is it? Concave what? Concave up. Okay? So when you know vertex form, there's another specific attribute that we haven't talked about in a while that you have to know the vertex form. Anybody know what that is?
The axis of symmetry.
Axis of symmetry. Ooh, I didn't mention that last class. Axis of symmetry. What's your AOS here? How do you write it? X equals -3. So if you know your vertex, you know your AOS. What's another one? We already got y-intercept.
Domain.
We don't know the x-intercept. Domain? What's the domain? Actually, you should know the domain on everything. All row numbers.
You know the range.
You know the range. You know the range because your y value of your vertex has to do with your range. Okay? So if this is concave up, how's your, it's like this. What's your range look like?
-5, infinity.
Very good. -5 to infinity. These are all the things that we need to be piecing together over the next couple of days. What was your question?
How did you get the divided by 2 again? Like, I got a little confused there.
Over here?
Yeah.
So when you create your perfect square trinomial, so you're trying to create this, okay? You have the squared. You have the 2 times a times b. If you're trying to undo that, you have to divide that b value by 2 because that's the number that you're actually squaring.
So if there's like concave, like you know how there's like a 3 sometimes, like in vertex form before the parentheses, would you like multiply it?
We're going to get to that on the next page.
Oh, okay.
Okay, because that's going to, again, we're trying to get the process right now. There's a slight difference. It is a tiny bit harder if your A value is not 1. And yes, that will be something we need to consider. But we're going to get there. We're just not there yet. You're on the right track, though. Okay? All right, let's try number 2. You guys want to try number 2 on your own?
Yeah.
All right, try number 2 on your own. you are going to have to carry that with you when you do your b divided by 2. And that sign is also going to carry when it comes to your perfect square trinomial. Okay? So I'm going to kind of work a little bit slowly, and if you get stuck, you kind of check with mine. If you get done, just chill for a sec. Okay. I wrote the vertex point again. That's not technically part of your answer, but I'm trying to kind of keep this stuff fresh on your mind so that way when we review 3 forms next week, you're like, oh, that's easy. Really, your first topic of your test, 3 forms and transformation, that should be like easy. Should be easy. Should be quick. Okay? Hardest thing on those are the ones where you have to like write the equations from like points or graphs or things like that, and you have to like find A. But that's the hardest part of that topic. The converting is definitely where you just have more skills to do. Okay? So that's how we do completing the square. Again, we started first with our A value being 1, but this is the process. When A is not 1, the process is not very different, but there is one thing that we kind of have to consider there, okay? Are you ready to try the next couple? We're almost done. I'm going to do, oops, went the wrong way. I'm going to do 3 with you, let you try 4, and then I'm going to do 5 with you, so that way you kind of get to see like each type of problem. There's a couple more on page 21 for you to practice, but when I'm done going over 5, I'm okay if you guys go to your homework. And again, there's extra practice built in. So, you were asking for extra practice. There is some in the notes packet that I didn't make y'all do, so you could always go back to those as well. Okay? So, 3, 4, and 5 are what if your A value is not 1? Again, a slight difference. Slight difference. Okay? So, let's see where it is. Step 1 is still to move our constant over. All right, so let's talk about the equation on y equals 2x squared plus 4x minus 6. When we factor, are we listening? When we factor, we are always checking for greatest common factors, step number 1. That's when we're factoring. When we're completing the square, we don't have to have that thinking cap on. Okay, so do y'all see that there's a GCF on this problem? Cool. We're completing the square. We don't need to deal with that right now. So our step 1 is to move our y-intercept over, all right? So don't get hung up on that. It's not really going to make your life a whole lot easier. You don't need to do that right now. Yeah.
I was going to ask if
So if you take out the GCF at the very beginning and you write it 2 times blah, 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 you can't move that number over once it's in parentheses like that. So really it's not going, you're going to have to put it back in. So don't do it there, okay? You are going to take something out, though. So let's add this over. So we have y plus 6 equals 2x squared plus 4x. So when we create our vertex form, y'all remember your vertex form, it was a, and then it's always x minus h squared. And that binomial squared is always 1x plus or minus something. So when you have an a value that is not 1, after you move the constant over, this is the key, after you move that constant over, then you are going to take out the a value on the right-hand side. And it's just the a. It is not the GCF. It is just the a value. So I'm leaving y plus 6 right here for a minute. And then I'm going to factor out what is my a value? 2. Just the 2. Fight the urge to take out the GCF that I've been stressing for days. Okay, on this, it's just a different skill. So this is going to become 2 times, when you take out the 2, you're left with x squared plus 2x. Okay, so that's the first thing, is take out that a. That a could be positive, that a could be negative. You just solely take out the number. Okay, so that's a new step. Then you're going to use your b value, but it is the b value with the a divided out. So the one that I circled. What is that b value? 2. We're still dividing it by 2. That's not changing. What is 2 divided by 2? 1. We're still squaring. That is not changing. What is 1 squared? 1. We're still going to add that value to both sides of our equation, but here's where it gets different. Okay, I'm going to do the right-hand side first. I have a factor of 2 that I took out on my right-hand side, but it is still there. So this on the right is going to say 2 times x squared plus 2x plus 1. And the 1's in parentheses. But how did I really change the right-hand side? I didn't just add a 1 on the right. I added a 2 times 1. Do y'all see what's really going on here? I put a 1 just in the parentheses, but what if I were to try to move that, what is that 1 really got to be multiplied by? 2. So that means over here, I have to my 6, I have to add 2 times that number over there. Okay? This is what people mess up on right here. They take the A out, they do all of this right, they put it on this side right, but they don't remember to, what does it say in bold? Multiply the added number by the A as well. So I have something that I do, I'm going to show you on number 5, that I think kind of helps people remember to do that. But that's the kicker. After that, everything else is the same. So when it comes to cleaning this up, 2 times 1 is 2. So really I'm doing y plus 6 plus 2. What is 6 plus 2?
8.
So I have y plus 8 is equal to 2 times, all right, x squared plus 2x plus 1. If I factor that, that becomes x plus 1 quantity squared. Again, it's still this guy,
Wait, where did we get x squared from?
The perfect square.
the perfect square trinomial.
Oh, you just didn't show
I haven't showed the factoring on a couple of them
I
now.
feel like you okay.
Yeah, I ran out of room, so I had to jump over here. But remember, it's the b divided by 2. That's the number that should be in that binomial squared every time. But if you forget what 2 numbers multiply to be 1, add to be 2. 1 and 1. And then what am I going to do with the plus 8? Bring it back over. So my vertex form is y equals 2 times x plus, it's not a very good, plus 1 squared minus 8. And that's my vertex form. Okay? We okay? Let's talk about 5 together, why we're kind of locked in, and then I want you guys to go back and try 4 on your own. Okay? I would tell you, just like I said, you're going to have hard factoring on the test. You're going to have some difficult completing the square. You're going to have A values to deal with when you complete the square. So practice. Okay? All right, last one I'm going to work with you is number 5. What's your A value on number 5?
-5.
So what's your concavity on number 5? Down. Okay? But we have an A value that's not 1. It doesn't change our first step. We always have to take that y-intercept and move it. So I have y plus 6. I feel like we've been doing y plus 6 quite a bit. Or was it just 3? Yeah, it was just 3. Maybe it's all running together, all my classes. So y plus 6 equals negative 5x squared plus 10x. Okay, I want to show you how I think maybe this might help you not forget about the A value here. So next step, I want to divide out my A value, which is negative. It's not going to change too much, but I am going to take out a negative 5. Be careful with your division. Negative 5x squared divided by negative 5 becomes positive x squared. That should always happen.
Yeah.
Positive 10x divided by negative 5 becomes...
-2.
You're right. I don't know why I wrote a 5. It is negative, though. Negative 2x. Okay? I was trying to emphasize the sign, then I messed up the number. Negative 2x. Okay? But you do have to have that sign flip right there. Okay? So here's what I do before I go over and start doing my b over 2 thing. If I ever take out an A, this might help you. This might help you. I immediately go and start writing my left-hand side. And I'm going to go ahead and put that factor, that A value that I just took out. What kind of A value did I take out? So I'm really adding what kind of number? which really means I am subtracting. I kind of go ahead and do this little setup right here. Before I even start b over 2 squared it, I kind of just like, again, as a reminder to myself, hey, the number I'm going to plug in right here, I've got to multiply that by whatever that a value is. Positive, negative, whatever. And then I go about my merry way. So maybe that will help you. This is the step right here that people miss every time. It drives me bananas, okay? So please, 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 don't be that person. All right, now let's do our side work. This is my not very good number. We're taking negative 2 and dividing it by 2, and what do we get?
Wait.
Negative
I thought it was
one.
negative.
What?
I thought you divided negative. Oh, it's that.
I'm back over here. Back over here. Negative 1 squared is
Negative
1. No, 1. And that's what I'm going to add to both sides. X squared minus 2x plus 1. But I already got that it has to be multiplied by that factor. I already got it on the left, so I shouldn't forget it.
Shouldn't it be plus 5? Because it's like the
Right here?
Not that one, the other one. The one in, yeah. I mean, like minus 5? Because it's like.
No. And when I write it in the undistributed one, I just put that number directly in there. It's when you put it on the other side that you have to do the multiplier. Okay? So this becomes negative 5 times 1 is negative 5. And so then it's 6 minus 5. What is 6 minus 5?
1.
So y plus 1 equals negative 5 drops down. Now I do my factorization of this guy. Okay, if you remember, you can grab the b over 2, and that's the number that's going to slide right in your binomial squared. But if you forget, just factor the trinomial. And then swing it over. Your vertex form is
Y equals negative 5 times x minus 1 squared minus 1.
and you're done. Again, it's a much faster process than factoring, hard factoring, okay? Much faster process. But it is a little bit weird. They have kind of some crazy rules you got to watch out for. It just takes practice. If you practice this like heavily the next couple of days, you should be fine on the test, okay? But you got to make sure you understand the process. So I want you to do 4 for sure. Then you can go to your homework and start working on those. But if you need more practice, I think 6, 7, and 8 are great as well. And I'm going to come check homework in just a minute.